Welcome to Ask and Learn.
All right, so in this question, we are given a partial structure. Give me just a moment to write that out for you. Looks like this, and they are labeled as bond 1, 2, and 3. It wants to know how many hydrogens we need. These are all going to satisfy the octet rule, which means each of these carbons needs 4 bonds. I'm going to start at the end that has the carbon that has the third bond there, the bond labeled number 3. This carbon already has 3 bonds, so it just needs a 4th to make its octet. The carbon in the middle has 3 bonds to the carbon to its right and 1 bond to the carbon to its left, which means this octet is already satisfied. Moving 1 carbon to the left of that, this carbon between bonds 1 and 2 has 2 bonds, so we need a 3rd and a 4th to get to 8 electrons or 4 bonds. The carbon at the left-hand side of this has 1 bond to another carbon, which means it needs 3 hydrogens. So counting those up, we have 3, 4, 5, 6 hydrogens. Okay, that was the first part of this question. Next wants us to rank this from shortest to longest. The more bonds you have between atoms, the shorter your bond is. So a single bond is going to be longer than a double bond, which is longer in turn than a triple bond. So bond 3 is going to be shortest. And then bonds 1 and 2 are going to be the same length. Okay, they're tied because they are both single bonds. The third portion of this question wants to know which of these bonds is the strongest. This is the opposite of length of the bond. The shorter your bond, the stronger that connection is. I have to break 3 bonds between the carbon-carbon here at bond 3 versus only having to break 1 in either 1 or 2. So bond 3 is going to be the strongest. Remember, in that triple bond, you're going to have that sigma and then 2 pi bonds. You're sharing 6 electrons. So because of that, it is going to be a very strong bond.